Alright guys, it's your boy Mapoy here with a periodic table practice exam to help you guys go over the types of questions you're expected to try and be able to answer on Monday's test. Alright, so let's start with number 1. Atoms of which element have the greatest tendency to gain electrons? So let's see. Let's underline this keyword here, greatest tendency. So greatest tendency to gain electrons, we're thinking about electronegativity. So for number 1, you need to think about electronegativity because it's all about the strength of attraction for electrons. So you should know that fluorine has the highest of 4.0. You could also use table S to compare each of those four elements. But if you already know that fluorine is the highest offhand, then you don't have to worry about using table S. So it's choice 4, fluorine. Alright, number 2. From the list below, which first ionization energy would indicate the most reactive metal? So we're talking about ionization energy. So high ionization energy means you want to keep your electrons. If you have low ionization energy, that means you want to give it up. You want to give up. Want to react. You're also very reactive. Because by giving up your electrons, you're offering to bond with other elements. You're offering to react with them. So from there, it'll be choice 2. 500 being the lowest. Alright, number 3. An atom of aluminum in the ground state and an atom of gallium in the ground state have the same what? So aluminum and gallium. So let's cross off some choices. So they obviously have different masses because they're different elements. They have different masses. And because of that, they also have the same totally different number of protons. Different elements have different number of protons. It's what identifies them. Now, electronegativity and total number of valence electrons. If you're going to see on the periodic table, now if you happen to have your reference table on you, which you should, if not, you could easily look up and Google the chemistry reference table for yourself. But anyway, you should see that aluminum and gallium are in the same group. That means they're right on top of each other. So Al and Ga, gallium. So if they're in the same group, that means they have the same number of valence electrons. So that is choice 1, same number of valence electrons. Number 4, a solid element that is malleable, a good conductor of electricity, and reacts with oxygen is classified as what? So let's look at the keywords: solid, malleable, good conductor of electricity. Those are characteristics of a metal. That's choice 4. They're all characteristics of metals. Number 5. An atom in the ground state has a stable valence electron configuration. This atom could be an atom of, so stable valence electron configuration. So stable meaning full valence. That means they have 8 valence electrons. So they are noble gases. So we're looking for anything in group 18. And that's any choice 1. Alright, number 6. Which element requires the least amount of energy to remove the most loosely held electron from a gaseous atom in the ground state? So we're talking about ionization energy. That means you should look at table S. So table S will help you find and compare those values. Or what you can do instead is know the trends. Metals have very low ionization energy. So let's cross off those that are non-metals. That's bromine. Now, if you're going to answer the rest of this, you need to look at table S to see and compare the other 3 metals. So by looking at the ionization energy values, you're looking for the one with the least ionization energy, and so that would be sodium with about somewhere in the 400s, Calcium is somewhere in the 500s. Silver is higher than that, so it's sodium. Now, what number are we on? Number 7. What is the net charge of an ion that has 8 protons? So that's a positive 8. 9 neutrons, so that's 0. And 10 electrons. So positive 8 minus 10, that equals a negative 2. Choice 4. The chemical properties of calcium are most similar to the chemical properties of, so similar chemical properties, that means we're looking for those in the same group. Same group. So let's see here. So calcium here is group 2. Potassium is group 1. Magnesium is group 2. Sc is group 3. And argon is group 18. So it's magnesium over here, same as group 2. In which section of the periodic table are the most active metals located? So the most reactive, so the metals are on the left side. So let's cross out choice 2 and 3 because metals are on the left side. Now the upper left corner right here, let's draw this out. Okay. So the upper left corner is where hydrogen's located. It's actually it's not even a metal, even though it's in group 1. So that means going down here, we're looking for the most active metals. That's the lower left corner, right down there, right with francium and cesium. Alright, moving on to number 10. Pure silicon is chemically classified as a metalloid because silicon, so let's think about metalloids. Metalloids share characteristics of both metallic and non-metallic. That's the main premise of metalloids, they're in between. Number 11. Which list of elements consists of a metal, a metalloid, and a non-metal? So that means let's start with looking at the metals. Which of those 4 choices starts off with a metal? So, choice 1, oxygen is a non-metal, so that's not an answer. Now looking at 2, 3, and 4, chromium, lithium, and tin are all metals. So they're good so far. Now let's look at the metalloid. Or actually, yeah, let's go with the metalloids. Alright, let's look at choice 2, MO. Molybdenum is not a metalloid. Si, silicon, is a metalloid. And A, sodium, is a metal, so our correct answer is choice 3. So let's look at each of those metal elements. So Sn is tin, that's a metal. Si, silicon, it's on the bolded staircase, and it's also our classic metalloid. If you look at number 10, you should know it's a metalloid. And C is carbon, it's a nonmetal, so it's choice 3. Alright. Number 12, which element can be brittle or soft in the solid phase and is a poor conductor of heat and electricity? So number 12, we're looking for nonmetal. Those are characteristics of nonmetals. Okay, so nonmetal. Copper is a metal, calcium is a metal, strontium is also a metal, so that leaves us with sulfur. Sulfur is in the nonmetal section on the right side of the periodic table, and it's not touching the bold staircase, so it's definitely a nonmetal. Alright, number 13. Which grouping of circles, when considered in order from the top to the bottom, best represents the relative size of the atoms of lithium, sodium, potassium, rubidium? So that means, if you look at each of these elements, they're all in group 1 here. Hydrogen's right here, lithium is here, Na, potassium, and rubidium. So if you notice going down the group, their size is going to increase because they increase in electron shell. So the further down you go, the more electron shells you add, the bigger it gets. So since they're already in order going from top to bottom, we're looking for a small one to start off with, going bigger as we go down. So it's choice 2. Number 14, which trend appears as the elements in period 3 are considered from left to right? So let's look at number 14. Let's draw our periodic table here. Okay, period 3 over here. So metallic character is one of those things we have to consider. So metallic character. If you remember on the left side of the periodic table, we have our metals. So metals are all on here and nonmetals here. So going from left to right, we become more non-metallic. So we lose that metallic character. So it decreases going across. So cross off 1 and 4. Now electronegativity. Let's remember that fluorine is the highest electronegativity value. So if we get closer to fluorine, our electronegativity increases. So it's choice 2. Number 15. Which set of properties is most characteristic of transition metals? Colors, for sure. Now if you look at their oxidation states, that means you need to look at, let's look at cobalt as our example. That means you look at this top right corner. You look at that, and then you'll see if it's positive or negative. So cobalt, one of its example charges is 2+. So it's definitely positive. It has multiple oxidation states that happen to be positive. Okay. So we're looking for colored. We cross off 2 and 3 because they say colorless. We're looking for colored. And it has multiple oxidation states. There, positive oxidation states. Alright, number 16. Which element is correctly identified according to family and period? So family meaning the group, the name of the family group, and period. That means in the row it is. Element 10. So let's look at... Oops. Let's go with purple. Okay. So element 10 happens to be neon. Neon is a noble gas and it's in period 2, but it says it's a halogen, so nope, not that one. Number 11 is sodium. That's an alkali metal, not an alkaline earth metal, and it's also in the wrong period. Nope. Okay, number 17 here is chlorine. It's a halogen, and it's also in period 3, but let's see. It's a halogen in period 3, that's correct. So we already got it. Alright, number 17. Base your answer to the following question on the chart below. So we're looking at this chart. Which element is an inert gas? So inert gas meaning it's stable. Which means we're looking at noble gases, group 18. It's in group 18. Alright, so here we're looking at an element that's all the way to the right side in the last column, and that's choice E. Because look over here, we're looking at this one, so there's letter E over there. Number 18, the chart is a periodic table with only 14 main groups. Which element has the lowest ionization energy? So looking up over here, helium is around here. It has the highest. So going opposite helium over down here, you have the lowest. So out of these, it's II, choice E. Number 19. Which of the following statements apply when an atom of chlorine becomes an ion in a chemical reaction? So before it wants to bond with anyone, it needs to become an ion. So chlorine has 7 valence electrons, so it usually becomes an anion, a charge with -1. So that's choice 2 is correct. Statement 1 is incorrect. The ion is larger than the atom, so remember, anions are bigger than the atoms. But atoms are bigger than the cations. So the ion is definitely larger than the atom, which makes statement 4 incorrect. So we're looking for 2 and 3. Choice C. Number 20. In which area of the periodic chart will be found the most electronegative elements? So fluorine, we should remember, is our highest, and it's in the top right area. So it's section C. The elements on the periodic table are arranged in increasing order of atomic number. Remember that. So left to right, top to bottom, it goes from 1 all the way to 118. Alright, so here let's go up every 2 boxes for 100. And this is for number 22. Okay, so every 2 boxes on the y-axis, let's go up by 100. Oops. Let me get my pen out. Okay, so right here is 100. Here is 200. Here's 300. Here's 400. Here's 500. And over here is 600. Okay, for ionization energy. Okay, so that's our axis. Number 23. State the trend in first ionization energy for the elements in the table as atomic number increases. Oh, actually, we're supposed to plot these points. So over here, you plot them. So atomic number 3 has a ionization energy of 520. So that's around here. Let me do that a different color. Okay, so it's over here. Number 11 has 496. So it's closer to 500. 419 for number 19. Okay. 403 for rubidium, which is number 37. Remember, 37 is over here, all closer to the right. 403 over here. And 376 for number 55. So there's not much of a change. But as long as you correctly plot it, like that, you'll start to see that it decreases. Explain in terms of atomic structure why cesium has a lower first ionization energy than rubidium. Let's see. Let's compare cesium and rubidium. So they're all group 1, so they have 1 valence electron each. But cesium versus rubidium, cesium has 6 electron shells. So that means I'm going to try to draw 6 circles here. So there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6 here. Versus rubidium having just 5. There's 1, there's 2, there's 3, there's 4, and 5. Okay. So cesium having more electron shells, more shells leads to further distancing. So that means they have weaker hold of electrons, of those valence electrons, which is why cesium has lower ionization energy. It has a weaker shield because it's so far from the center that nucleus can't really hold on to its electrons that strongly compared to rubidium, which is smaller in size. Cesium being bigger has a weaker hold on its electrons. Okay? Alright, 26. Write both the name and the charge of the particle that is gained by an F atom when the atom becomes an F minus ion. So it's all about losing and gaining electrons. So electrons here are the ones being gained, and it's a negative charge. Okay? 27. Explain in terms of electron shells why the radius of K plus is greater than the radius of Na plus. So Na plus versus K plus is this, 288. So Na plus has 2 electron shells versus potassium, which has 3 electron shells. Okay, so radius of K plus is greater because it has more electron shells. Leads to bigger radius. Okay. 28. Determine the charge of a UUT nucleus. Your response must include both the numerical value and the sign of the charge. Okay. That means you got to look on the periodic table. So UUT is going to have an atomic number of 113. So if it has an atomic number of 113, it has a nucleus that has 113 protons. So each proton is plus 1. 113 protons would be positive 113, which is the charge of the nucleus. So positive 113. Identify one element that would be chemically similar. So we're looking for an element that's in the same group. So because it's in group 13, we can pick any element in that same group. So let's pick aluminum. That would be a valid answer. So with boron, gallium, indium, etc. Draw a Lewis electron dot diagram from atom of UUT. So because it's in group 13, it has 3 valence electrons. So UUT would then look like this. 3 valence electrons like that. So we finally reached this part 2 short answers section. I mean, we did a little bit in the previous few pages, but here's some extra short answer parts dealing with periodic table. So here, part A, which element has the highest electronegativity? So we're looking for something that's in the relative position of fluorine. Fluorine's all the way up in the top right-ish area. So let's use G. Which element is the most metallic? So we're going all the way to the left side near the bottom. So let's B, element B. So the further down you go, the more metallic it is, and all the way to the left. If you go all the way to the right and to the top, the least metallic it is. Now, which element has the greater atomic mass? So something that's all the way further down and to the right. So that's F. Further down you go, the more shells you add, the bigger the mass. Which element is most chemically similar to A? So that means same vertical column, same group. That's B. Which element has the smallest atomic radius? So that's something all the way to the... So we're looking for an element that's closer to the right side, given that the trend. Atomic radius goes down as you go across, left to right, and towards the top. So that's element G. Now, part F, I kind of told you to skip this question, and I was looking at the chart. I was like, there's no way we could answer this looking at the chart. However, I wasn't reading the prompt above. So it says here, all elements are chemically reactive. Noble gases are chemically inactive. They don't like to react. So none of these elements are noble gases because all of these here are chemically reactive. Noble gases are not reactive. So all of them are chemically reactive. Explain why, as the atomic number increases in a group on the periodic table, the size of the atom increases. So why does it increase in a group? The size of the atom increases. So let's see, you add more electron shells. So what 3 conditions of an atom control for its strength of attraction and size? Okay. Think of subatomic particles. So let's see. Let's think of nuclear charge, which relates to protons. Number of valence electrons. And let's also think of electron shells. Okay, so those are the three conditions. Electron shells definitely play a role in size. Valence electrons definitely with strength of attraction as well as nuclear charge. These things all come together to determine strength of attraction and size. Alright, so we are looking for elements 51 to 54. So that's looking at Sb, antimony, tellurium, Te, iodine, and xenon. So we're going to look at table S for their ionization energies. So antimony is 831. Tellurium is 869. Iodine is 1008. And xenon is 1170. So let's plot these on the table, on the chart. So Sb is 51, that's 831 over here. Tellurium is 869. Iodine is 1008. And xenon is over here. So it looks like it goes up like that. Now number 5, so going back to number 4, looking as you go across the period, it does follow the trend that it does increase, plus you're going to the right side closer to fluorine, so you're getting stronger, you're increasing. Number 5, explain in terms of atomic structure why cesium has lower first ionization energy than rubidium. This is a repeat of number 30, so you could go back there and check out the explanation. But cesium has more electron shells, which leads into further distance from center, from the nucleus. So from there, because you're far from the nucleus has a weaker hold on valence electrons. Okay, and that's it.